the angle of elevation of the top, x, of a vertical pole from a point W on the same horizontal ground as the foot Z of the pole is 60 degrees. So we are saying that we have a vertical pole. And the angle of elevation of the top of the vertical pole from the point W. So these are points W. So say these are points W, points of elevation of the top on the same horizontal ground as the foot Z of the pole. So we say here is Z. And the angle of elevation from W to the top of the pole is 60. So the whole of this is 60. If W is 15 kilometers from X, so W is 15 kilometers from X and 12 kilometers from a point Y on the pole. So say here is Y. From W to Y, we have 12 kilometers. Illustrate this information with a diagram. So this will be the diagram, and B. So A. B. Calculate correct to 2 decimal places the angle of elevation of W. BI. Calculate correct to 2 decimal places the angle of elevation of Y from W. So we want this angle. We don't know, so we name it theta. But we know so we have 2 triangles. First, the bigger triangle and the smaller triangle. So we have X, W, Z, and 60 degree. Then we have this triangle too. Y, Z, W, and this is phi. This is 90. This is 90. This is 12 kilometers. This is 15 kilometers. And we are being asked to find this. So first, we need YZ. This is the adjacent. This is the opposite. So to find YZ, we can use cos. So cos 60 we know is cos 60 is equal to adjacent, which is WZ, over hypotenuse. And our hypotenuse in this case is 15. So we can say that WZ, WZ, so line WZ will be equal to 15 cos 60. So WZ will be equal to 7.5 kilometers. So we can say here is 7.5 kilometers. So in this triangle, in this diagram too, so in this diagram, we can also use cos to find the theta. So cos theta is equal to 7.5, which is the adjacent over the hypotenuse, which is 12. So theta, cos theta will be equal to 7.5 divided by 12, we get 0.625. So theta will be equal to the cos inverse of 0.625. So theta would be equal to 51.32. So corrected to 1, how many decimal places? We are being asked to leave our answers to 2 decimal places. So theta will be equal to 51.32 degrees. So therefore, the angle of elevation of Y from W is 51.32 degrees. Now we are asked to find B. So for B, let's move to B. B is calculate correct to 2 decimal places, II, the length of XY. So we are finding the length of this. So first, we need to know XZ. We need to know XZ. And we need to know YZ. So we can say that XZ should be equal to YZ plus XY. XZ should be equal to this XY plus this YZ. And from here, we know our WZ is 7.5 kilometers. So we can find our XZ using Pythagoras' theorem. Or we can also use trigonometry to find XZ. So for trig, we use sine 60 is equal to XZ over 15. Then our XZ is equal to 15 sine 60. So we have our XZ to be equal to 9.3678 kilometers. Now we can do the same thing for this smaller triangle. So for this smaller triangle, we can find YZ using trigonometry. So for that one, we have sine 51.32 is equal to YZ over 12. So YZ is 12 sine 51.32. So this angle is theta. From our solution, theta is 51.32. So then sine 51.32 should be equal to our opposite, our adjacent, over 12. So YZ then becomes so 15 sine 60 is 12.99, by the way. Okay, so our YZ becomes 12 sine 51.32, which is 9.3678. And we know that YZ is equal to, and we know that XZ is equal to YZ plus XY. And we are being asked to find XY. So XY is equal to XZ minus YZ. So XY is equal to 12.99 minus 9.3678. We can say that line XY is equal to 12.99 minus 9.3678. So line XY is equal to 3.6222. So correcting this to 2 decimal place, we have XY is equal to 3.62 kilometers. So that brings us to the end of question 11. So we move on to question 12.